Ladies and gentlemen, I am Dr. Claudia Albers, Planet X research and professional physicist. And today I'd like to bring to you another one of my articles. This one is entitled Stellar Cores are Gravitational Poles or Superprotons. Now, Planet X system stellar cores are the name I have given to the group of objects which I started seeing in spacecraft and satellite images of the Sun at the end of 2016. They are able to very closely approach the Sun but never collide with it. They have a weak gravitational influence on other matter. They come in different sizes. Only the larger ones are cores of stars. Smaller ones of the size of a small planet and even much smaller than the Earth are obviously the cores of planets or small moons. However, we will continue to use the term stellar core to mean the cores of all celestial objects. Planet X system stellar cores have low gravitational influence because they are low in gravitational energy or photon energy, in other words light, which exists within particles. Light within particles determines the strength of the gravitational interaction. And you may look at Book 3 entitled Planet X Reveal Gravity and Light for more details. Stellar cores also enter into the Earth's atmosphere. And here I just have these diagrams that summarize the electrostatic or the electric interaction, the gravitational interaction. And basically they oppose each other. And it causes a proton, the gravitational would cause a proton and electron to repulse each other. They repel each other. But in the electrostatic interaction, a proton and an electron attract each other, whilst two protons repel. And in the gravitational, they attract. And also, the strength of the interaction is the same in all three cases here. It just, as I will show later, it becomes infinitely strong when they try to approach each other very closely. But the gravitational interaction, the strength of the interaction, depends on the light within the particles, or the photon energy, or what I sometimes call the gravitational energy within the particles. Now here we see some of these objects, these Planet X system stellar cores. This one is in the Sun's corona, and it is absorbing matter from the Sun. There's a gravitational vortex below it. There is another one that seems to be covered in coronal plasma. And here's one in the Earth's atmosphere. As you can see, it's an object partially covered in cloud. They seem to cause cloud formation around them. And you can see part of it is exposed here. You can see it's a spherical object. It is inside the Earth's atmosphere. And you may look at Article 410 entitled Planet X Inside the Earth's Atmosphere for more details. These objects enter the Earth's atmosphere just like they enter the Sun's coronal atmosphere and interact with the Earth in the same way as they were observed interacting with the Sun. They created solar tornadoes or gravitational vortices with the Sun's surface as a result of the tidal force they exert on matter at the surface. They are thus able to draw material toward their surface and through that mechanism gain gravitational energy. They do the same with the Earth, though the tidal force they exert on Earth matter, or through that, they are able to create low pressure weather systems with cyclonic rotation in the Earth's atmosphere. And it is in fact impossible to have a low pressure weather system in the Earth's atmosphere without these objects being the source of it. And this is illustrated in these two diagrams, where if you just have a region of low pressure, in other words, low density in the Earth's atmosphere, then air surrounding it would quickly flow in to equalize that density and therefore that pressure. So it is only when a stellar core is within the Earth's atmosphere that through its gravitational interaction and the gravitational wave which it creates in the atmosphere, that it can create a region of low density than normal for the rest of the atmosphere between itself and the surface of the Earth. And you may look at Article 484 for more details. These objects will also create a gravitational wave on the surface of the ocean. The interaction goes all the way down to the surface and causes a wave pattern on the surface as well, a region of high and low density. And through this, so just like the low pressure region they create in the atmosphere, they create a region on the surface of the ocean that has lower density. And they also create a region of higher density, which is a region where the gravitational force becomes repulsive and the Earth's surface gravitation seems to increase. These regions of gravitational reversal create ocean recession events, which can only be tidal in nature and which seem to have started occurring in 2017 when stellar cores capable of creating larger gravitational vortices capable of influencing the ocean in this manner started entering the Earth's atmosphere. And here you see some of the results of that. We can see that the ocean receded here, and this is in Uruguay and this is in Brazil. And this occurred in August of 2017. So this was an unprecedented low tide, just because the water came back, and could only have been created through a tidal force of an object that approached Earth from outer space, very closely approached Earth. The larger the area affected by the gravitational wave or vortex which they create on the ocean surface, the larger the object giving rise to it is likely to be. These objects are always accompanied by a huge debris field, and you can see one of these objects here accompanied by huge amount of other smaller objects and material, and you can see some very large objects here. Some of them seem to be covered in cloud-like material. And so this object actually turned out to be larger than the sun. Some of these objects are extremely large because they are the cores of stars. But the smaller ones would have been planets that would have been part of these star systems. And planets have a core, which we can call a stellar core as well, and then they have material around that core. Some of that material will be molten, become magma, and then it has an atmosphere. And when the stellar cores form, when the Planet X system stellar cores formed, in other words, they actually died. They lost gravitational energy to the point that they could no longer attract their outer layers of material strongly enough, and it instead exploded outwards away from the core and became this debris field that now surrounds the object. The debris pieces enter the Earth's atmosphere when the objects approach Earth and attract water so that cloud forms around them. A large portion of the debris is in the form of dust, which causes the formation of clouds at different altitudes, which are often colored as the debris material inside absorbs energy and therefore light from the Earth's atmosphere. As the debris absorbs energy, it moves down through the atmosphere and is eventually able to reach the surface. The water which formed the cloud around the debris dust falls as rain. You may look at Article 509 for more details. And here you see a diagram which illustrates that the gravitational energy of the planet decreases as we move down towards the center, and then the debris which has the highest gravitational energy will form clouds very close to the ground. In other words, fog, and debris, dust that has a slightly higher gravitational potential will form clouds a little higher up, and dust which has very low gravitational potential will form clouds at very high altitudes. And here you see a bank of cloud which advances along the ground toward a city in China. So this formed around dust which had quite high gravitational potential. Of course, it's still much lower than dust which is belongs to the Earth, was always part of the Earth, and is on the surface of the Earth would have, which is why it remains suspended in the atmosphere. Now, there are also large pieces of broken planet in the debris field which will enter the atmosphere when the core approaches Earth or enters the atmosphere. The larger the pieces, the longer it will take for them to absorb enough energy to reach the surface. And these pieces may thus remain suspended in the atmosphere for a very long time. Stellar cores themselves never touch the surface, and I have said that this is due to the fact that they are positively charged, which is true. But there is more to it than that. Stellar cores are not like normal matter. They are sources of gravitational field. They are gravitational poles, and like protons within the nucleus of an atom, they can therefore be called superprotons. Protons attract each other very strongly within the nucleus but never collide. The force of attraction is extremely strong and is thus called the strong nuclear force. But it becomes repulsive once the protons approach each other beyond a certain limit. And the repulsive force very quickly tends to infinity at closer distances, so that protons cannot collide. This occurs because both approaching particles are positively charged, and the electric force or the electrostatic force becomes infinitely repulsive at such close distances. And this is illustrated here in this diagram. So if you have two protons in the nucleus, they will be strongly attracted to each other due to the strong force, which is the attractive, it's the same as the attractive part of the gravitational force. And the green arrows represent the gravitational force. So they're strongly attracted to each other up to a point. They will reach a minimum distance where now, and the orange arrow is the electric force, where the electric and the gravitational force have equal strength. So that means they stop being attracted to each other at that point. But if they have an initial velocity that will cause them to move any closer than that, then suddenly the gravitational force drops it may drop to zero or close to zero, and the electric repulsive force becomes extremely large, and very quickly it will tend to infinity, so that they are strongly repelled by each other, so that they can never collide. And the same thing happens with stellar cores. Matter which is not a part of a stellar core is different, therefore, than from matter making up a stellar core. This matter responds to the presence of a stellar core and is attracted to it. This matter behaves like a fluid if it is in small pieces in comparison to the size of the stellar core, and develops wave-like effects to the point that gravitational vortices form, which are actually gravitational diffraction effects. You may look at Article 403 for more details on that. Gravitational diffraction manifests in the form of a vortex. Water in a sink going down a hole creates a vortex, which is a diffraction effect due to water being acted upon by gravity through a small hole, which acts as a source of gravity. This is illustrated here, how a small amount of water going through this hole will just go right through. There will be no diffraction effects because the hole is large compared with the size of the water going through, of the matter under the action of gravity. But when the sink is full of water, the hole is small compared with the amount of matter that is being attracted and pulled through the hole. So now the hole acts as a source of gravitational field, and diffraction effects arise in the form of the water vortex. You can see it occurs on both sides. And the same thing happens with light. Light, in the form of free photons, acts in a similar manner when forced to move through a small hole or slit. And the slit is small because it's of comparable size to the wavelength of the light. And then the slit acts as a source of light, and it results in a diffraction pattern. Thus, matter which is not a part of a stellar core acts like electrons in a nucleus. They respond to the attraction of a nucleus and gather around it. In this way, a celestial object is like an atom and may be called a superatom. And just as an atom, it has several energy levels or layers, starting from the magma layer down up to the atmospheric layer, which has the lowest gravitational potential. And gravitational potential is gravitational energy per unit mass. And here you see a diagram representing the different energy levels that a planet would therefore have. There's, of course, the stellar core at the center, which has the highest gravitational potential and the highest density. After that comes the molten rock layer, which is actually positive ion plasma, or otherwise magma. And the most positively charged layer will be the stellar core itself, which is extremely positively charged. This one will not be as positively charged as the stellar core, but it will be more positively charged than the solid rock layer beyond that. And the energy level, the energy of the matter within it, in other words, the gravitational potential of the matter decreases as we move outwards towards the surface. And the matter with the lowest gravitational potential will be the matter that makes up the atmosphere. And the density of that matter will also be the lowest. Matter is reaching protons up to the surface, but the atmosphere contains more electrons than protons. The surface matter is neutral and will thus contain as many protons as electrons. But electrons are different. They are negatively charged. So they have negative gravitational potential. And that means that electrons, which predominate in the atmosphere, increase in gravitational potential as we move outwards towards the upper atmosphere. Stellar cores vary in size and most likely in gravitational energy as well. The smallest and weakest are only able to draw material from the Earth's atmosphere, and thus material which belongs to the Earth's lowest energy level. Stronger stellar cores will be able to draw water from the surface and possibly solid matter such as loose dust and rocks. The largest and strongest will be able to draw matter from the highest energy level of drawable energy, i.e. from the magma part of the Earth. Stellar cores which draw this highest gravitational energy matter seem not to attract matter from the other levels. It is as if they differentiate between energy levels and only draw from the energy level right below their own. For example, some stellar cores were observed only drawing atmosphere from the sun, whilst others did not draw atmosphere but drew denser matter from the sun's liquid surface or chromosphere, whilst even larger and stronger stellar cores drew matter from so close to the sun's core that a huge quantity of plasma often erupted towards them from way inside the sun, thus creating huge CMEs, or coronal mass ejections. And here you see one of these stellar cores. This one is only drawing coronal plasma, or the sun's atmosphere. This one has a vortex under it, and it looks dark and seems to therefore be drawing material that is denser and comes from a lower layer in the sun. That would be the chromosphere, which seems to be made of liquid, or basically magma. The magma goes right up to the surface of the sun. It will do that with all stars as long as they have their atmosphere in plasma arc mode. And then there are these huge stellar cores which seem to be strong attractors of the strongest energy matter in the sun. the matter that has the highest gravitational potential, which is from low down in the chromosphere. And so these CMEs, these huge CMEs, seem to erupt from low down in the chromosphere of the sun. And you can see this object turned out to be 7 times larger than the sun. You can see some of this plasma that's erupting from the sun in front of it, so we know it's very close to the sun. And this object disrupted the sun to such an extent it attracted this plasma from deep within the sun, and so it erupted towards it. Now here we see a stellar core which is in the Earth's atmosphere, and we can see that it's a stellar core because what seems at first to be a break in the clouds actually has a convex surface. So it's actually a spherical object poking through a layer of clouds. So it's in the Earth's atmosphere, and it is surrounded by pink and gray cloud, which would have formed around dust and which would be a part of the object's debris field. The object seems to be drawing atmosphere and is thus a weak stellar core. You can see this seems to be material which it is drawing. It's gray because it's basically water and its energy is being absorbed, and in turn, it absorbs light from the atmosphere, which is why it is then gray or dark colored. And this must be happening due to a stronger stellar core, stronger than this one, up here within this cloud layer. The cloud would have formed again around the dust, which is part of the object's debris field. The object itself is inside there, but it's stronger because it is able to draw water, which exists on the Earth's surface and has thus much more gravitational energy than material in the atmosphere. So it is able to draw this water and it forms, so this is a water spout. So this is a water spout stellar core inside there. And so thus the largest and strongest stellar cores will draw plasma from deep within the Earth and will not affect the atmosphere or the ocean. They will, however, cause volcanic eruptions and earthquakes. And here you see illustrated how one of these strongest stellar cores will attract molten rock from inside the Earth. That's the magma within the Earth, and it will then, if there's a volcano, and they'll most likely be attracted to volcanoes because that's where that material, the molten rock, is closer to the surface, and then they will provoke these volcanic eruptions. And that's illustrated here. You may look at Article 505 for more details on this. And volcanic eruptions and earthquakes are basically the same thing, caused by a stellar core which closely approaches the Earth and again attracts this plasma from inside the Earth, which is high in gravitational energy. But in this case, there's no volcano. So the matter from inside the Earth goes as high as possible. There may be channels from previous eruptions which resulted in earthquakes as well, but the channels do not reach all the way to the surface, so there is no volcano, no opening to the surface. But the magma will go as far up as it can. It will then cause some kind of explosion which may break up the Earth some more at that point, and that creates an earthquake at that point. So stellar cores will form as a result of the electric interaction when a star or galactic nucleus goes through a matter creation event, in which case very high energy photons move through a very high electric field, which causes matter to appear from within the photons. The matter appears to be a fluid at first, but it condenses into a celestial object with a core, i.e. a stellar core or a source of gravitational field. This is what Alton Harp observed and described was occurring in the universe in his book, Seeing Red. Active galaxies were ejecting matter, which was condensing into quasars, which eventually turned into galaxies. And you may look at Article 126 entitled White Holes Instead of Black Holes at the Center of Galaxies. So in conclusion, Planet X system stellar cores are sources of gravitational field and act as superprotons. All celestial objects have a stellar core at its center. Matter which is not a part of a stellar core responds to it and behaves as matter in different energy levels outside the nucleus of an atom, i.e. like electrons. A stellar core attracts matter which is close to it in gravitational potential and does not attract matter that is much lower than it in gravitational potential. Only the largest and strongest stellar cores produce CMEs and volcanic eruptions or earthquakes. And these are the references. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.